Hey guys, how's it going? I'm meteorologist Kylie Bearse, and for today's science and weather lesson, we are going to talk about something that we don't really get here in Colorado. But from my experience doing school visits, whenever I'm talking to the second graders, they always love talking about hurricanes. And so that's what we're going to talk a little bit about today. It's just going to be a really basic kind of beginner's intro to learning about hurricanes. And then I am going to link to a couple more sites if you want to learn a little bit more and go more in depth to learn about these tropical cyclones. So starting off with hurricanes, or since we get them all over the world, they do have different names in different parts of the world. So in general, cyclone will kind of cover all of it. Typhoon certainly used quite a bit. We used hurricane here when we're talking about North America. And then down toward Australia, they call it a willy willy, which is a really hilarious name for something that is very, very serious. But willy willy is one of the things that you call it. And so what is a hurricane? Well, a hurricane is a very, very large rotating storm with winds that start around 74 miles per hour, and they form over really, really warm ocean waters. So starting off with those warm ocean waters, this is why we don't see them in Colorado. Hurricanes need water. They usually impact states that are closer to the ocean, and since Colorado is landlocked, we just don't see them. It'd have to be a really, really massive hurricane, and that would be bad news if we ever saw one. But kind of looking at the map of the world, so here's the United States, and you can see where hurricanes form. They're down toward the equator, not quite on the equator, just a little bit north or a little bit south of it, and that's where we can see some of those really, really warm ocean waters. And so how warm? We're talking 80 degrees or warmer just for those ocean temperatures. And what the hurricanes need are those warm ocean waters, because they're going to pull a lot of that moisture up and help it build into clouds. So what happens is we've got that warm, moist air that's sitting right above those really warm ocean waters. That is going to rise, and as it does, it's going to form those storm clouds, because we start to see that. And so as it rises, it's replaced by cooler air below it. Eventually though, that warms, that rises, and we kind of get this circular pattern that goes up and creates these massive, massive storm clouds out over these ocean waters. So kind of if we were to cut a hurricane in half, here's what it would look like. So you can see all of the different parts in there. We've got the eye right in the middle where air is actually sinking down, and that creates some kind of clearing effect. So sometimes it's even blue skies in the eye of the hurricane. And you can see the eye wall, and then all of that warm, moist air that's just spinning around it in that circular motion. So storm clouds, they actually, once we see that happening, once those storm clouds get going with those really, really warm ocean waters, they start to get bigger and bigger. Well, we know that the Earth spins, and we call this the Coriolis Effect. And so with that, the storm clouds begin to rotate with the Earth. And so when you're north of the equator, so the northern hemisphere, they actually will spin counterclockwise. And then for the southern hemisphere, they spin clockwise. So that's why we start to see that spinning happening, because the Earth is spinning. Now, a couple different parts of the hurricane. We already went over just a little bit of this, but the eye of the hurricane, that's that part in the middle that you can see right there. Now, there are almost no clouds in the eye of the hurricane. So you could look up, you could see bright blue skies in the eye of the hurricane because of all that air that's sinking down. The wind, pretty much calm. And so here's kind of the scary part about the eye of the hurricane, is that it can be completely calm, but then as soon as that eye moves past you, you enter the eye wall, and that's the strongest part of the hurricane, the most dangerous part, because that's where we get the strongest winds. You can kind of see that kind of right around there. And so you go from eye wall, where it's incredibly strong and dangerous, to inside the eye, where you have almost blue skies sometimes and really calm conditions, to once again in the eye wall. So just remarkable when we're looking at that. Another part of the hurricane would be the rain bands, and you kind of see those. You kind of have a good idea here. So you can see these bands that come out, and they have incredibly heavy rain that comes along with it. So flooding, a big concern when we're talking about hurricanes making landfall. They've got those rain bands that are just dumping water, but also the storm surge. So that means that it's going to push that ocean right up into land and cause pretty severe flooding with that. And then of course the wind, another very dangerous part of the hurricane when we're looking at that. So again, there's the eye right in the middle. We've got those hurricane force winds kind of right in the surrounding areas. And then as it goes out, it gets a little bit weaker and weaker as it does. So the farther out from a hurricane, the weaker it is, or farther out from the eye, I should say. Okay, so how big is a hurricane? Hurricanes are massive. They can be more than 600 miles wide. And this is one of the biggest, or biggest, they call it typhoon tip. And so this one was at one time 1,400 miles across. When we're looking at that, we've got Colorado right here, we've got Dallas here, and New York there. You look at how much of the United States that would take it up. Now, of course, it didn't hit the United States, but that's just if you were to overlay that on top, just to give you an idea of just how big these hurricanes or the typhoons can be. Hurricane season, at least for the Atlantic and the Caribbean, starts on June 1st, so we're about a month out from that right now, and it goes until November 30th. So that's kind of the biggest time frame when we look at the hurricanes. So how do we measure hurricanes? Well, the way that we do it is by wind, and we do it by the Saffir-Simpson scale. It starts at about 74 miles per hour, and so that's when it would go from being a tropical storm to then a Category 1 hurricane. So from 74 to 95 miles per hour, that will be considered Category 1. Once you hit 96 miles per hour, Category 2. And then you get into the major categories like Category 4, 130 miles per hour, and then Category 5, 157 miles per hour, or even higher than that, which we've seen in recent years when it comes to those hurricanes. Now, one thing that the kids always love and that people find really interesting is that the National Hurricane Center, this is one of the only storm systems that we actually name, at least for meteorologists. When it comes to broadcast meteorologists, we don't really use the naming when it comes to winter storms. So these are the only names that we use when it comes to storms. So the National Hurricane Center has the name set for the next 6 or 7 years. And so they use alphabetical order. So starting at A, they go to B, C, D. They alternate between boy and girl names. So you can see this year, the first hurricane that we see will be Hurricane Arthur, and then Bertha, and then Cristobal, and then Dolly. You can see it goes on and on and on. So they've got quite a few different ones. The only ones that you won't see as far as letters go, we're talking the letter Q, U, X, Y, and Z. They don't have any names that start with those, at least for the hurricane. So these go out, and I'm gonna link to the National Hurricane Center so you can see all of the names for the next several years and see if maybe your name or a family member's name is on there. So pretty cool. It's always kind of fun to see that. Okay, how about we do an experiment now? Let me go ahead and close this. And this one's really, really simple. And it's just me, so I gotta take a second just to raise this on up. All right, so you guys can see what I have for you. Okay, we're gonna tilt this down. Here we go. Okay, so this is really, really simple. You probably have everything that you need at home already. So I'm gonna go ahead and bring this right about here. Okay. So a big old bowl filled with water. I went ahead and filled it before we got started. You need a spoon and then some food coloring. Okay, so here's what we're gonna do. We are just going to, and anyone can do this at home, spin the water around. So go ahead and give it a stir for maybe about 30 seconds to a minute so you can get it going really, really good. So what we're doing, we're creating that spinning, the Coriolis effect. And what's going to happen is you wanna grab your food coloring, have it ready to go, and we're going to drop the food coloring right into the middle and watch what happens as you do. Ooh, see it kind of spins out and continues spinning, and you can almost see those bands just like we were looking at. It might be a little tough to see here, but when you do it at home, just put in 1 or 2 drops, and you can see how most of the food coloring is really, really tight in the middle, and then as it goes out, it gets weaker and weaker and lighter, just like a hurricane does, where you can see all of those bands. And so you can make your own hurricane in a bowl right in your kitchen. Pretty cool. Have fun, guys. Tag us in your pictures as you make them.